Hello guys and welcome back to my video tutorial. I'm doing another video tutorial that follows my previous video tutorial on the IGCSE Paper 2 Solutions Part 4. So if you haven't seen that video tutorial, you can go to my channel and you can look at the last video tutorial that I did for Part 3 and Part 4 when we started to look at a new IGCSE Paper 2 Computer Science scenario and questions. So today what I decided to do was I was going to be looking at the questions for we're going to be looking at how to answer the questions for this scenario, this program scenario that we were looking at for the computer shop. And I just want to pinpoint some things that I talked about last time in the program that I had forgot to mention, and I want to mention them out. So I'm going to go back again to the program and just talk a little bit about that. And then we're going to be looking at some of the questions. So mind you, this does not contain all the questions for paper 2. I just decided to take the questions that are related to the program. But if you would like me to do more video tutorials that does involve the other part questions of section B for paper 2, please let me know in the description, in the comments down below, and then I'll do my very best to do those parts. So I'm just going to do the questions. I'm going to explain how you can answer the questions related to the scenario of the program for this paper. And by the way, this paper is for May-June 2018. So let's get started. So if you remember from the previous video tutorial of part 3 and 4, we have done this program which was about a computer shop, and basically what they wanted was that the customers, or you could say the users, were able to place orders based on the stock level, and if of course the stock number was available for each order, they were able to place it. So your program was basically asking users to enter their choice of processors, their choice of RAM, storage quantity, screen size, etc. And then your program was supposed to check back with how much they wanted to buy of each component if it was available, and update the stock level numbers, and basically print an order at the end of the day, and sort of like an estimate. So that's pretty much the overall of the program. The only thing I would like to drag your attention to is this part here. Last time I actually forgot to mention this, and so I need to mention it now. Whenever you ask the user to choose a certain component, it's important that the price of that component, of course, based on the question, because if you go back to the question again here, you're going to see that each component, whether it's processor 3 or 5 or 7, have their own specific prices. So it is important to note that the price, to know the final price of a particular component, you have to multiply it by the quantity based on what the user would like to pick or choose if it's available. So it's important to point this out. I forgot to mention this last time, so please take note that you need to definitely times your component price by the quantity of that specific component. Be it if the component is P3 for processor or P5 or any other component, you still have to times it by the processor quantity, which is what I'm doing here. If you guys notice, I'm timesing it by the processor quantity for each processor. And as you can see, I'm timesing it by this processor 5 quantity because that relates to processor 5. So it's very important to take note of that. And the same thing goes for the RAM. It is important to also times, again, based on whatever the user would choose for RAM choice, when you are deducting or deducing, not deducting, but deducing the price for RAM, it is important to times the price of the RAM that you're given, of course, in the question, which each RAM component is different, times the quantity that the user would like to buy. So that's definitely reasonable to be able to find the total price correctly, and then of course to apply the discount. So this applies for all of the other components. And then towards the end, of course, this is where you come down and you start to find the total price like I talked about last time, and of course you apply the 20% discount. So this is all I wanted to say. Really, I don't necessarily need to run this program again. I have run it in my previous video tutorial, so you can go just check that out. And if you have any questions, you can let me know in the comment section, and I'll do my very best to get back to you. So let's get back into our main business. And our main business today is to look at the questions for this past paper. So if you look at the questions for we're going to start with question 1A. Question 1A says that all variables, constants, and other identifiers should have meaningful names. So they always put this kind of like notification for you to take note of. And then they said, you've recorded information for the estimate of the cost of building a computer in task 1. It says, give a data structure that you created for task 1, its name, its data type, and use. So what you need to do whenever you see these kind of questions, it's always important to go back and look at what task 1 is. And task 1 was all about allowing the customers to make a choice for each component and then producing an estimate and, of course, assigning a unique estimate number and the components, the estimate number and the components chosen and the price of the component. So basically, task 1 involves the user making the choice of what kind of component they want, but also involves creating an estimate, and this estimate should have a unique estimate number per customer, the components that they've chosen, and the price of each component. And of course, to calculate the total price with a 20% of, plus a 20% added to the price. So 20% of the final price and added to the price itself. So this was very important to also do. So basically here they're asking you to be able to to give the data structure that you created for task 1, its name and data type and use. So if we go back to our program, so this is where you need to go back to your program. Since task 1 is all about allowing the user to make choices and based on the components they would like, and then producing some sort of estimate where it contains the estimate number, the components chosen, and the price. So you need to think about the data structures that you've used. So for example, you can definitely say, so I'm just going to go back here. So the data structure could be, definitely it's going to be an array. It's a one-dimensional array because you stored everything of one dimensionals. If you realize, and if you have a look at my program, you would see that we created one-dimensional arrays to store the processor, the RAM, the storage quantity, the screen size, the case type, and the USB ports. The reason for doing this was because we wanted, whenever a user would choose a certain processor type, we would have to check and see if that processor exists in the processor array. So this is pretty much what they want you to do. Since task 1 is all about allowing the user to make a choice and then creating an estimate, so they're asking you to basically talk about the data structure. And once you hear the word data structure, it means they're referring either to arrays or they're referring to dictionaries and sets. These are pretty much the data structures that we have available. So in this case, we didn't use anything of sets or dictionaries, but we used arrays. So this is what they're referring to. So they're referring to the arrays that you used for the processor and the ones that you used for the RAM and storage and screen size and case and USB ports. So in this case, you don't have to give all of them, since the question does tell you to just list out a data structure. So that means, what is the data structure? You're not going to give the name of the variable, but they're asking you for what kind of data structure you use, which should be an array. And now they say give the name. So now you can give the name of the variable. You could choose any one of these data structures you've used. In this case, I could go with processor. And then the data type is basically going to be string, because you can see that the data stored inside of the processor array are all of string types. So that's pretty much what you should write here. And then of the use, you can explain. So if you decide to take processor as your example for answering this particular question, because you have about 5 more of the other data structures, so you can use any one you like. But if you decide to take processor as your example, then of course you're going to say, well, the use of this array was to be able to store multiple or different types of processors. So that's what you're going to explain for question 1AI. So that's what they're asking you to do. And that's pretty much what I have also indicated here in the marking scheme. And then task 1AIII is basically asking you to describe the data structures that you've used in task 2 to record the customer details and include sample data in the description. So again, you're going to have to go and look at what task 2 is, and they're asking you to describe the data structure that you've used to store customer details. And if you realize in task 2, it says that you will need to use your estimate from task 1 to check if the components are in stock, and if all the components are in stock, you update the levels of the stock. And then it says add the unique estimate number to a list of order numbers, so they've told you what to do. And then it says add the customer details, today's date, the estimate details to finalize the order, and print 2 copies, one for the customer, one for the shop. So the question is asking you to describe the data structures that you've used to record customer details. So that's the key word here, guys. There's pinpointing exactly what they want you to explain to them, because task 2 does not only involve recording customer details, it also involves recording estimate details. It also involves including today's date. It also involves doing other things, but they're only asking you to explain how you were able to record customer details and to give an example data of what it looked like. So in this case, customer details would definitely be something like customer name, would be address, and then of course would be you could say telephone number. So it says describe the data structures. That's another key. So they're actually saying data structures with plural. So they're not saying one data structure. So you can't really say, oh, I created a data structure called customer details. I created an array called customer details, and I pretty much just stored everything about the customer in there. No, that's not what they're asking you. They're saying describe the data structures. So it means more than one data structure. So that would mean the customer, one array that will store customer name, one that will store customer's address, and one that will store customer's phone numbers. And so that will, of course, contain all of the information of the customers in sequential order as they place their orders. So that's pretty much what they want you to describe and explain what kind of data structures you created, which in this case are one-dimensional arrays or lists to store customer names, addresses, and phone numbers. And then they want you to give them an example. So you could say customer name equal, and then you put inside the square brackets, for example, Alex Rodriguez. And then you say customer phone number, and in speech quotes, again, you put a long phone number that's of string type. And then you say customer address. I think I already said, no, customer address. And then you put the customer's living address. So pretty much something like this is what they want you to explain. They said 1 mark for the data structure, 1 for the data type, and then 1 for. Okay, so I was saying that for question 1 AII, it's asking you to basically give the customer the data structures that you've used to store customer details. And here it says that you give the data structure is 1 point. That means you say you used an array. And then the data type, of course, which is string, that is going to be storing the customer name and is going to be storing the customer address and phone number. So that's pretty much what you're going to explain as well. And the sample data, which example you can see here, John Smith, and then where he lives in Cambridge and his phone number. So that's pretty much what they want you to do for question 1 AII. For question 1B, it says that you need to explain how your program for task 1 produces a unique estimate number. So guys, if you remember in task 1, it was all about allowing the customer to make a choice for each component and then producing an estimate which contained a unique estimate number. And one of the simplest ways you can do this is basically create a variable called estimate number, which is what we did in our program, if you guys remember. We had a variable called estimate number, and we initially set it to 0. Anytime a user would come or a customer would come and make choice of all the components they would like after successfully placing their orders, then the estimate number would increase by +1. So that's how it kind of was unique for every customer, because it had like a +1 increment, which I'm going to show you guys here. So that's one way you can explain it, that initially you create a variable called estimate number, which you set to 0, and then you pretty much increase by 1 anytime a customer places an order. You could explain it that way, or you could create an array that's a one-dimensional array or list. And sorry guys, and then inside of the one-dimensional, maybe you could call this one-dimensional array or list, you could call it estimate number. I'm just showing you as an example, guys. And then in here, you're gonna basically write, for example, unique numbers. I don't know, you could do something like E101 or 102, and then you can assign these numbers to the customers anytime an order is placed. So let's say whenever an order has been successful, all of these choices have been made successfully and it's been placed, then once it comes to the end, you basically just maybe use a for loop, because you're going to have to loop through the array that you just created for estimate number. And the for loop variable, like you say for x in estimate number, which is what you created at the array at the top. And then you basically say order number is equal to x, or estimate number is equal to x. And so you save that for each customer, and then that's basically going to make it unique for everyone. So that's another way of how you can do it if you wanted to do estimate number, uniquely. So there are many ways, but one easy way is, like I said, just set it to 0 and then +1 every time an order is successfully placed. So that's pretty much what you need to explain, and I think that's what I did. So I said a variable called estimate number is declared and initialized to 0 at the start, which later increments by 1 every time an order is placed successfully. So let's look at the next question. The next question is question 1C, and this question says, write an algorithm for part of task 2 to check that the chosen processor and chosen RAM are in stock. Using either pseudocode, programming statements, or flowchart, assume that task 1 has been completed. Do not check other components or produce the order. So what they're asking you guys to do for this one is, again, remember that task 1 was all about allowing the customers to place their order, checking and seeing that these orders are actually in stock, and then creating an estimate. And so from task 1 extending to task 2 was the part where you'd have to produce copies for the customer and the shop. And of course, it was the part where also stock levels needed to be updated, and then customer details needed to be present in the estimate with a unique estimate. In the copy you're going to be producing with a unique estimate number and the today's date and the estimate details. So that was what task 2 was about. So you need to understand what the question is asking you. So the question is asking you, either you use pseudocode, which is an algorithm, which we haven't seen in our video tutorials yet, but I'm planning to do them soon. So if you'd like to learn about pseudocode really much, and we are going to actually run pseudocode and you see how it does run. And if you'd like to learn how to do flowcharts, please let me know in the comment section and I'll try to do more videos of that. But basically today for this question, we're going to stick to the programming statement. So they're asking you to include programming statements that you've used in your program that allows your program to be able to check based on the processor chosen and the RAM chosen if they are actually in stock. So basically that means if you go back to your program, when the user basically chooses a particular processor of their choice, your program then checks, it asks them for the quantity of that component. Then it checks using an if statement to check and see if what they have actually entered for the quantity they want is actually less than the stock number of that component that is available. And so for testing purposes, I put for every single component, the initial stock number to be 3. Of course, you can put any stock number you want, but that was for testing purposes. So anytime a user would enter a particular amount they would want for a component, then an if statement will be able to compare and check and see if that particular amount that they've entered is actually less than the stock number that I initially placed for that particular component. And so that's how the program is able to validate and update the stock levels. If it is less than what is available, then it means that the customer can place their order successfully, which is why we have this message. But of course, if it is something that is more than what is available, then of course a message would be displayed to the customer saying that they've entered a large amount that is not available in stock, and the flag that we use as a control goes to false and it breaks out of this loop. So this is happening for all of the other components. So what they're asking you for this question is just basically to paste or to include programming statements from your program that actually check to see that the chosen processor and RAM are in stock. So they're telling you, do not check other components or produce an order. So they don't want you to show them any orders, or they don't want you to show them any other components apart from processor and RAM. So what you're going to do in this situation is you go back to your program and you pretty much copy everything from the beginning of where you've asked them to enter the processor of the choice all the way to the RAM part and all the way to the end of the validation, and you pretty much just paste it. So what they're really looking to see is, so you copy it first and then you go and paste. So what they're looking to see is this part here, guys. They're looking to see where this if statements are present that actually validates the amount of the specific component entered and does update the stock level, which is what's going on here. So stock level does get updated anytime an order is successfully placed and the number of quantity of a specific component that the user or customer requires is less than what is available. So that's what they're really wanting to see. So if you're doing programming statements, if you decide to choose programming statements instead of pseudocode or flowchart, it means you're going to copy everything from the beginning here all the way to the end, like I said, only for RAM, since they say that you should not include any other components. So you copy that and you pretty much paste it, which is what I did here, guys. And you can also well, when you're doing an exam, you have to write it out. So you could make it shortened if you'd like. Maybe just do only one component for processor and one for RAM, and you pretty much maybe circle or highlight the part of where the comparison is made and the updates is made for the stock level. So this is what I've done. I just copy pasted that part, guys, and that's pretty much the end of what they require for this question. You notice that they do not ask you to explain anything, so you don't need to explain. They only tell you to use either these algorithms for pseudocode or flowcharts or programming statements to justify how your program has been able to check and see that processor and RAM chosen are in stock. So that's pretty much what you need to do for that question, guys. As I said, now we're moving to question 1D. Now, this is the last question for Section A. And again, Section A of the IGCSE Past Paper 2 normally focuses on questions that relate to the program they've asked you to create based on the scenario you were given in pre-release. So this question basically asks you to explain how your program completes task 3. Any programming statements you use must be fully explained. So what they're telling you here is that you can use programming statements and include them as support to your explanation, but you must explain. So the key word here is explain, unlike the other question where they asked you to just use either programming statements, pseudocode, or flowchart to justify the answer. So they said write an algorithm. They didn't say explain. So that's the difference. Always take note of these keywords. So let's see what task 3 is about. So if you go back to task 3, task 3 basically says you need to summarize the day's order. So you need to extend task 2 so that it provides an end of day summary showing the number of orders made, the total number of each component sold, and the value of the orders. So that means this is the part where you actually created a sort of like end of day summary estimate for the shop administrator, which then shows the number of orders that have been made, the total number of components sold for each component, and the value of the orders, which means basically the total cost. What was the total complete cost for all orders? So they're asking you to explain how you've done task 3 and also include any programming statements to support your answer or explanation. So what I did for this part was I explained what we did. If you guys remember for task 3, when we're supposed to produce this end of day summary, we did it in this part where I actually had some sort of validation. I just randomly created a password which would only be for the shop administrator, because obviously we don't want customers to see the end of day summary except only the shop administrator, who can then see what has been sold in the shop and what's left and etc. So this part I already explained in the previous video tutorial. So this is pretty much what they're asking you to explain all the way from here all the way to the end, really. It's a very short part. So in this section, what I did was I said the number of orders made was gotten from the estimate number, since the estimate number was indeed increasing by 1 starting from 0. So it does indeed tell you as well the number of orders made because it keeps increasing by 1. So that's pretty much what I explained here. And then for the components sold, I said a variable had been declared and set initially to 0, which was again increased by 1 anytime a successful component had been sold at the end of placing the order. So if we go back to our program, basically what I was explaining for this part was, I'm going to try and find there it is. For example, the USB. When the user decides to choose any USB port, for example, if they chose 2 ports, then of course many things happen when the quantity that they want is basically available in stock. First, the price is calculated by multiplying the price for the component by the quantity chosen, and the stock level is updated by subtracting the quantity they've chosen from the present or current stock number for that component. But also a variable I created called USB to sold for every single component uniquely would also increase by the number of components they want for that, the number of quantities they want for that component. And so this would determine how many of those, how many number of things have been bought for a particular component. So this is pretty much what I have explained here. That does explain how every component sold is being, how the value is being calculated for every component sold, which is what they're asking you in task 3. So it's basically increased, not incremented exactly by 1. I would have to make a change by this, guys. It's not incremented exactly by 1. It's actually incremented by the quantity, like I said. So that was a typographical error. I will make a change to it. So it's increased by the quantity because if they say they wanted, for example, three things or of three USB 2 ports, then the amount sold would be that particular USB 2 sold, which was set initially to 0 plus 3, and it keeps increasing anytime such quantity is placed. So please recall, it is not incremented by 1. This is a typographical error. I was probably thinking about the counter thing, but it is actually incremented by the quantity. So I'm going to make a change for that. So the next thing was, I said, in the case where a successful order had not been placed because one or more components were out of stock, then the sold variable will not increase by, again, it will not increase by the quantity sold, but instead the quantity the user would requested, so this is where I actually talk about the quantity, will be subtracted from the component sold, so as not to count it as sold. So guys, this part, I'm really explaining this section, which I think I can show you if I go back to processor. Whenever the user successfully places an order, so we, like I said, the sold amount will be increased by the quantity they requested. However, if they have requested a quantity that is greater than the original or the current stock level or stock number of that component, then, like I said, what I was trying to say, again, I'm going to just show you for the RAM. So let's say that they place the RAM and initial stock for RAM was 3, stock number was 3 for RAM 16 gigabytes, and they want to buy 4. So if they want to buy 4, obviously they cannot place an order. It's not going to be successful because 4 is more than the initial stock number. So in that situation, it's going to tell them that they've entered a large amount. And then if the program has successfully successfully accepted any processor that they've chosen, it will now subtract the amount of whatever processor they've chosen from that particular processor in this and store it under this processor, whatever component, in this case P3 sold. The reason it has to do this is so that it does not make any updates. It does not update anything with the estimate, as in it does not show that a processor has been sold because the order was not placed because they have chosen the second component, which is the RAM, whatever they chose, 16 gig or 32 gig. They've chosen an amount that is more than what is in stock. And if you remember, in the past paper, they said anytime an amount for any component is chosen that is out of stock, that is not available, then a firm order cannot be placed. A firm order can only be placed if all components are in stock. So in this situation, if they choose RAM 16 gigabytes that is more than what is in stock, then anything that they've already placed for any processor component has to be removed or deducted from the processor sold variable amount. So it should not reflect. And that's what's really going on here. Okay, so that applies for all of the other components. And that's what I explained in this part that I was talking about here. So I just had to explain that because it does talk about how exactly your program is going to be recording the value of every component sold. So you also have to explain the part of what about if a component that has been entered is not available in stock after entering another one before it successfully, what happens? So that's what I did. And then I explained that I said that an array called final price was declared to store the total prices of all orders. The sum function was used to find the total values of the orders at the end of the day. So what that means is if you go back to our program, guys, anytime the order is successful and the total price is calculated for each estimate, that is for each order, you notice that I have something called final price. So I created an array at the very top. If we go to the top, it's called final price. And the reason I created this array was so that it stores the total price for every single estimate. So at the end of the day, I could just sum up all prices using the sum function. So that's pretty much what I explained there. So this final order cost, which is the one that applies the 20% addition, will then be appended or added to this final price array, and then another variable called final total will be able to find the sum, that is the total price of the whole final orders that have been made. So that's pretty much what they're asking you to do, which is what I explained for task 3 as well. And that will be something that will be displayed for the total values of orders at the end of the day, which was what task 2 was explaining. And then I finalized this by saying all the above mentioned information is displayed to the shop administrators after the successful entry of a validated password and a report in a tabular form is displayed showing all information mentioned above. So I just made sure that I explained this part where I actually had to create some sort of validation method where I created a password. I set a password for shop administrator, and I only asked if there were a shop administrator and validated that before actually showing an end of day summary sales. So this part is what I explained here. So it's always good to be detailed, guys, when you're explaining, especially when it relates, when they ask you a question relating to a task. Try to explain everything about the task, unless if they don't specifically specify. For example, like in this question for 1C, when they only specified for, processor and RAM choice, that's when you be specific. But for 1D, they just ask you to show and explain how you completed task 3. So you have to be very self-explanatory so that they actually understand. And then it is always good to include programming statements that you've used in your program to support that explanation, which is what I did here. And I said programming statements included, and I just pretty much copy pasted this part of the code that had to do with the end of day summary sales, and I just pasted it in here. And guys, that's the end of this video tutorial. I will be doing another video tutorial that again covers some past papers, and also I'll start to talk about some interesting project ideas for computer science of how you could interpret real world problems into programs, working solutions as programs to create. And that could be very useful for some of you students out there who are going to do their internal assessment in IB, or even a project in computer science that involves creating working solutions to real life problems. I'm going to have to stop the video tutorial here, guys. I hope it had been useful for you, and I guess I'll see you in our next video tutorial. Thank you.